Welcome to Advanced Data Analysis 2 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, we will conclude Chapter 14 on cluster analysis. With this example of 1976, the bicentennial year for U.S., birth and death rates. So we're looking at 34 countries, and the birth rate and death rate, they're both defined as the number of births or deaths per 1,000 people of the population of the country. So it's a proportion of people who, it's actually per mil, per 1,000 people. So we'll read the data set in from the website. We've got the countries, the birth and death numbers, and here's the table of all these values. Of course, a plot is always the most useful thing we can do as a first step. And so we have birth rate along the horizontal axis, death rate along the vertical axis, and the countries. And just to poke our heads in to the data set a little bit, we got Germany, Austria, Netherlands, Switzerland, Japan in the lower left-hand corner where the birth and death rates are sort of low. And as we come across the bottom, we stay with low death rates, but our birth rates increase in Taiwan, South Korea, Malaysia, Mexico, China, and then the birth rate continues to increase, but the death rate also increases. Vietnam, Nepal, until we get up to Afghanistan in the top right-hand corner. We'll start by using complete linkage. Recall that complete linkage is the maximum distance between pairs of points between two clusters, and that's the measurement of distance we're going to use. And we'll find that with complete linkage we get these nice round clusters. After, we're going to look at single linkage, which uses the shortest distance, and we'll find that we've got these long strings of points clustered together. So that is one of the primary points of this example, is to show you the contrast between different types of linkage. In the previous examples we used average, so now we'll use complete and single, the two extremes. So we start with complete linkage. We convert our data set, the birth-death data set, to numeric, so we can run the NB-clust function on it to estimate the number of clusters. And of course we've removed that first column of labels before we put the distances into NB-clust. There's plenty of warnings. The suggestion among all indices is that 2 indices suggested 2 is the best number, 1 proposed 4, 1 proposed 5, and up to 15. So there's no real, even though there's a majority rule here, there's no real consensus. In fact, I'm surprised that 3 didn't appear. 2, 4, 5, 6 are our numbers. So we're going to have to take a look. I'm going to skip over all this garbage, the output for the different methods and these plots, and focus on the dendrogram. Now when we look at the dendrogram, I'm looking for sections of branches that are fairly long, which indicates that between, say, this, so I've chosen 3 clusters here, but before I chose that, I plotted this dendrogram, and I'm looking for branches that are fairly long that separate clumps of observations, clusters of observations. And so at 3, this is a fairly nice place to cut this. It looks down, down low. There's lots of countries that cluster very tightly in all 3 of these, and it's not until you get sort of up to 3, maybe a little bit lower, that you start to get large separation between groups of countries. And that is a function, of course, of using complete linkage as being the maximum distance. These are the types of clusters you get with complete linkage. Here's the way of plotting the data using the 2 principal components. And we actually have a little bit of overlap. Recall that our data set only has 2 dimensions, birth and death. But we have some overlap here, and that's just the way complete linkage creates those clusters. I'm printing out groups of countries here, but I think it's not as interesting as creating a plot and labeling the 3 clusters with colors. So we've got a group in the bottom left, which are, so I apologize, I'm not the best on world politics and stuff like that, but basically we have the industrialized countries in the bottom left, Austria, Switzerland, Germany, Japan, Canada, Argentina, I guess, down here. And then we've got these middle set of countries, Taiwan, South Korea, China, Indonesia, Ecuador. And then we've got this group up here, Vietnam, Nepal, and Afghanistan. And to the eye, these look pretty good as three clusters. Now, when I looked at this a little bit more, and one of my students approached me and said, well, what about these 4 right here? These 4 seem to be a little bit offset from the group on the left and offset from the group on the right. And if we scroll up to the dendrogram, I'm going to page up actually, we can see these 4 countries, Malaysia, Sri Lanka, Taiwan, and South Korea, as having a really long branch before these 4 join with everyone else on the right. So there's an argument to be made that to lower the height here to cut about here, which would cut this branch 1, 2, 3, 4 branches. So perhaps 4 clusters, if I page back down, would be the right number. And my student, who is politically savvy, suggested that those 4 Asian tigers that are these Asian countries, but they have very different features than the other countries, can make sense as their own group. Let's look at the same data, but instead of using complete linkage, which was the maximum distance, we'll use single linkage, which will be the minimum distance between pairs of points between clusters, as the cluster distance. So everything's the same except I'm using single as the method. I've made the font a little bit smaller so that we don't have quite as much to scroll through. You can see among all indices we still don't have a lot of consensus for the best number. The methods suggest 2, 5, 6, 7, and 11 as the number of clusters, and 2 methods give the number 6. When you look at the dendrogram, which is coming up shortly, I promise. Here we are. Wow, what a big difference between the complete and single linkage. Look at how long these branches are, and boy, it's not clear what which observations really cluster together, and you have to go way up high on the tree to cut it, but it's not obvious that these 2 huge clusters don't belong together any more than cutting it down lower. And if you did cut it lower, say where my mouse is right now, we end up with a few countries like these 2 long branches coming down here, Cameroon and Mexico, that end up all by themselves. So you really have to be careful with single linkage. It creates these strange clusters. Here's what it looks like in the 2 principal components. And in the plot, you end up with these long clusters. Basically, you start joining countries that are really close together, and then, because you're just looking at the minimum distance, the cluster sort of creeps. So there's no way for me to really just point and show this, but you can imagine, you're looking at the shortest distances. So it's the points at the edge. I don't have a way to really show this. Okay, so one difference here is that these 4 Asian tigers, the Taiwan and Sri Lanka and South Korea and Malaysia. These 4 were grouped to the right before, now they're grouped to the left. And that's because my hunch is that these countries in the bottom left are fairly close to each other. They're grouping together. And then you're looking at the boundary of this cluster and looking at the shortest distance of a little jump to these 4 countries. And this little jump, maybe from Argentina to Sri Lanka, was shorter than from China or these here jumping to the left. And so once you grab one into your cluster, then you can start making shorter hops and just eat up countries as you go. And these poor 2 countries, Afghanistan and Upper Volta, I think, end up staying away from everyone else because there was just too much of a rift here. So we have these long clusters and probably harder to interpret than the complete linkage for sure. So ultimately, my suggestion is to try the different methods, looking at different numbers of components, and because this is an exploratory method, you're not testing hypotheses that you had before you observed the data. There's really no really strong inference to make here. You're just trying to get a sense of what patterns exist in the data in terms of similarity between observations. So try different methods and find a story that is in the data that is compelling and is supported by other contextual evidence that you have about the data. Cluster analysis, you can think of cluster analysis as being fairly sloppy, and but just a way for you to explore the data. All right, that is the end of chapter 14.